Before we begin, a quick note about how this episode was created. This episode uses AI generated narration to bring Dr. Jackal's voice and character to life. However, the ideas, framing, and wording are my own. Dr. Alyssa R. Jones. The content has been synthesized, paraphrased, and adapted from history of psychology textbooks, scholarly work, lectures, professors, and other educational resources that have shaped my understanding of psychology, science, philosophy, and the mind. AI is used as a creative teaching tool, but the educational interpretation, organization, and teaching perspective come from me. Some wording may be condensed or adapted for clarity, accessibility, and narrative flow. This episode is designed to support learning, discussion, and historical engagement, and to invite students into the ideas, not replace the original sources. Episode 8. Evolution, Individual Differences, and Animal Minds Restored Full Conversational Version. Welcome back to Dr. Jackal's History and Systems of Psychology podcast, where we trace the strange, brilliant, and occasionally messy road that made psychology into a science. I'm Dr. Jackal, your lab mascot guide through the theories, rivalries, instruments, assumptions, and very intense 19th century confidence that shaped modern psychology. Today, evolution enters the chat. And once evolution enters the chat, psychology immediately starts asking a different kind of question. Not just, what is the mind made of? But what is the mind for? How does it help organisms survive? How does behavior help animals adapt? How do individuals differ from one another? And what, if anything, connects human minds to animal minds? In this episode, we are not just memorizing a timeline. We are tracking how psychologists changed what counted as evidence, what counted as science, and what counted as the mind in the first place. This episode takes us from Darwin's theory of natural selection to Galton's measurement of individual differences, Romanek's study of animal intelligence, Morgan's law of parsimony, and Spencer's version of social Darwinism. It is a big episode. It is also a dangerous one, historically speaking, because some of these ideas were used in harmful, biased, and deeply unjust ways. So today we are going to do what good historians of psychology do. We are going to trace the influence of these ideas without pretending they were harmless. Part 1. Darwin's core idea. Let's begin with the fundamental idea of evolution. At its most basic, evolution is the idea that living things change over time. Now, Darwin did not invent every piece of evolutionary thinking from scratch. Ideas about species change had been developing before him. For example, Darwin's grandfather, Erasmus Darwin, believed that all warm-blooded animals had evolved from a single living filament that had been given animation by God. In his view, God originally set life on Earth in motion, but did not continue to intervene by altering animal or plant species or creating new ones. Instead, animal forms changed according to natural laws as species adapted to changes in their environment. That idea is important because it shows a shift away from explaining each species as separately and permanently created. Instead, life was beginning to be imagined as something dynamic, changing, developing, adapting. Another important figure was the French naturalist Jean-Baptiste Lamarck. Lamarck proposed a behavioral theory of evolution. He emphasized that animals modified their bodily forms through their efforts to adapt to the environment. He also believed those acquired modifications could be inherited by later generations. So, for Lamarck, if an animal stretched, used, strengthened, or modified some body part in response to environmental demands, that change could be passed down. Today, we do not accept Lamarck's theory in that simple form. But historically, Lamarck mattered because he helped make adaptation central. He helped people think about living things as shaped by their environments. Then we have Charles Lyell, who introduced evolutionary thinking into geology. Lyell argued that the Earth had passed through various stages of development and evolved into its present structure over long periods of time. This mattered for Darwin because if the Earth itself changed slowly over vast time, then perhaps life could also change slowly over vast time. Another influential work was Vestiges of the Natural History of Creation, which described the evolution of plant and animal life and suggested that human beings descended from primates. So by the time Darwin published his own theory, the intellectual world was already wrestling with ideas about change, development, adaptation, and continuity across species. Darwin's genius was not that he was the first person to say living things change. His major contribution was explaining how that change could occur through natural selection. Part 2. Natural selection. Darwin observed that there is obvious variation among individual members of a species. Not every animal is identical. Not every bird has the exact same beak. Not every turtle has the same shell. Not every human has the same abilities, temperament, body, or tendencies. Darwin reasoned that some of these individual variations were inheritable. That means they could be passed from one generation to the next. This led him to the concept of natural selection. Natural selection is the process by which organisms best suited to their environment are more likely to survive and reproduce, while organisms less suited to the environment are less likely to survive and reproduce. In simpler terms, those who adapt are more likely to survive. Those who survive are more likely to reproduce. Those who reproduce pass on traits. Over many generations, those traits become more common. Life forms that survive the struggle for existence are the ones that successfully adapt to the environmental circumstances they face. Those that do not adapt are less likely to survive. Darwin was also influenced by Thomas Malthus, especially Malthus's essay on the principle of population. Malthus argued that the world's food supply increases arithmetically, while the human population tends to increase geometrically. That means population can grow faster than available resources. Darwin extended and adapted this idea. If more organisms are born than can survive, then there is competition. In that competition, some variations will be useful. Organisms with useful traits are more likely to survive to maturity. They are then more likely to transmit those traits to their offspring. Some offspring will show variations too, and some may possess useful qualities to an even greater degree than their parents. Over many generations, these changes accumulate. That is the core logic of Darwin's theory. And once that logic enters psychology, it changes the field. Because now psychologists begin asking, how does mind help organisms adapt? How does behavior support survival? How are humans continuous with other animals? Why do individuals differ? And what psychological traits might have functional value? That is a major shift. Part 3. Darwin's Long Shadow in Psychology. Darwin's work influenced psychology in several major ways. First, it encouraged the development of animal psychology, which became the basis of comparative psychology. If humans and animals are connected through evolution, then studying animals can help us understand human behavior. This was a major change. Before Darwin, many thinkers treated human beings as sharply separate from other animals. Darwin's theory raised the possibility of continuity in mental functioning between humans and lower animals. That possibility was intriguing and controversial. It suggested that animals might have memory, learning, emotions, intelligence, problem-solving, and social behavior in forms that could be scientifically studied. Psychologists began to realize that studying animal behavior might be vital for understanding human behavior. That helped motivate research on the mental functioning of animals. Second, Darwin shifted psychology's attention from the structure of consciousness to the functions of consciousness. Instead of asking only what consciousness is made of, psychologists began asking what consciousness does. How does consciousness help organisms adapt? How does it guide behavior? How does it help with survival? This shift would later become central to functionalism. Third, Darwin broadened psychology's methods. If psychologists were going to study adaptation, behavior, animals, individual differences, and development, they could not rely only on introspection. They needed observation, they needed comparison, they needed measurement, they needed data from many fields. Darwin's work made it more acceptable to use diverse methods and sources of evidence. Fourth, Darwin increased interest in individual differences. This is a huge point. Darwin's theory depends on variation. If all members of a species were identical, evolution could not occur. Individual differences are not noise. They are the raw material of evolution. Darwin observed many species during the voyage of the Beagle, and he recognized that variations among individuals mattered. Psychologists then began searching for ways that individual minds differed. That interest led directly into mental testing, measurement, statistics, and the study of intelligence. And that brings us to Francis Galton. Part 4. Galton Measurement, Inheritance, and Mental Tests. Before Sir Francis Galton, individual differences were rarely treated as an appropriate subject for psychological study. Psychology was more often focused on general laws of mind. But Galton made individual variation central. Galton was strongly influenced by Darwin's On the Origin of Species. He was Darwin's cousin, and Darwin's ideas encouraged Galton to undertake his own investigations into heredity, ability, and individual difference. Galton's first major book, Hereditary Genius, became important for psychology. In that book, Galton tried to show that greatness or genius occurred within families too often to be explained by environmental influences alone. His thesis was that eminent men tend to have eminent sons. He based this on investigations of the ancestries of prominent people of his own time. Galton believed his data showed that famous people inherited not only genius in general, but also specific forms of genius. In other words, he believed intellectual and personal greatness were mainly inherited. And this is where his work becomes both historically important and morally disturbing. Galton wanted to encourage the birth of people he considered more eminent or fit, and discourage the birth of people he considered unfit. He coined the term eugenics, meaning hereditarily endowed with noble qualities. He wanted to improve the inherited qualities of the human race. That goal shaped his work on measurement, testing, and statistics. So we need to hold two truths at once. Galton contributed substantially to measurement, statistics, individual differences, and mental testing. But he also promoted eugenic ideas that were harmful, discriminatory, and scientifically overconfident. His work is a clear example of how psychological measurement can be shaped by social values, power, and prejudice. That is why we study it carefully, not to admire it uncritically, but to understand its influence and consequences. Part 5. Galton's Mental Testing and Statistics. Galton developed early forms of mental testing because he wanted to identify exceptional men and women who, in his view, should be encouraged to reproduce. He even recommended that those who scored high should be offered financial incentives for marrying and producing children. To verify his eugenic theory, Galton studied measurement and statistics. He applied statistical concepts to problems of heredity. His data led him to conclude that eminent men were more likely than average men to father eminent sons. He did not believe environmental advantages, educational opportunities, or social privilege were sufficient explanations. Instead, he believed eminence was primarily a function of heredity. That is a very important historical point, because it shows how his assumptions shaped his interpretation of data. Galton also wrote English Men of Science and Natural Inheritance, along with many papers on heredity. He founded the journal Biometrica, established the Eugenics Laboratory at University College London, and founded an organization devoted to promoting his ideas about improving the mental qualities of the human race. Again, deeply influential, also deeply problematic. In Hereditary Genius, Galton argued that heredity sets limits on both physical and mental development. He believed no amount of mental or physical effort could allow a person to rise above their genetic endowment. But Galton was not satisfied with vague claims. He wanted to quantify. He wanted numbers. He wanted measurement. He was impressed by Adolphe Quetelet, who used statistical methods and the normal curve to describe measurements and errors in scientific observation. Quetelet used the phrase l'homme moyen, meaning the average man. This referred to the finding that many physical measurements cluster around the average or center of a distribution, with fewer cases found toward either extreme. Galton believed the same idea could be applied to mental characteristics. He suggested that two numbers could meaningfully describe any large set of measurements or human characteristics. This is one of Galton's major statistical contributions. He helped move psychology toward the measurement of individual differences. And that legacy continues in intelligence testing, personality assessment, psychometrics, and psychological measurement more broadly. But again, the historical warning matters. Measurement is never just measurement. What we choose to measure, why we measure it, and how we interpret it are shaped by assumptions. Galton's work proves that. Part 6. George John Romanes and Animal Intelligence. Now let's move from individual differences to animal minds. George John Romanes helped formalize and systematize the study of animal intelligence. He published Animal Intelligence, which is often considered the first book on comparative psychology. Romanes collected data on the behavior of many life forms, including protozoa, ants, spiders, reptiles, fish, birds, elephants, monkeys, and domestic animals. His goal was to demonstrate high levels of animal intelligence and to show similarities between animal and human intellectual functioning. In other words, he wanted to illustrate continuity in mental development. This fits Darwin's influence perfectly. If species are connected through evolution, then perhaps their minds are connected too. Romanes developed what he called a mental ladder. He used this ladder to arrange animal species according to their degree of mental functioning. But he tended to credit even lower life forms with high levels of mental activity. That enthusiasm became one of the main weaknesses of his work. Romanes relied heavily on the anecdotal method. The anecdotal method uses casual observational reports or narratives about animal behavior. For example, someone might tell a story about a dog solving a problem or an elephant showing grief. These stories can be interesting. They can even point researchers toward important questions. But they are not the same as controlled scientific evidence. Romanes also used introspection by analogy. This method assumes that the mental processes occurring in the investigator's own mind also occur in the minds of animals. So the observer watches animal behavior, compares it to their own human experience, and infers that the animal must have similar mental processes. For example, if an animal behaves in a way that looks like planning, the observer might assume the animal is reasoning in a human-like way. Romanes suggested that animals were capable of rationalization, ideation, complex reasoning, information processing, and problem-solving abilities similar to humans. His work helped prepare the way for comparative psychology, but it fell short of modern scientific standards. The line between fact and subjective interpretation was often unclear. Romanes opened the door, but later researchers had to make the study of animal behavior more rigorous. That brings us to Conwy Lloyd Morgan. Part 7. Parsimony, Morgan's scientific buzzkill. Now we meet Conwy Lloyd Morgan, and yes, he is the scientific buzzkill in the best possible way. Morgan proposed the law of parsimony. This law states that an animal's behavior should not be interpreted as the outcome of a higher mental process if it can be explained by a lower mental process. In other words, do not assume complex reasoning if simpler learning will explain the behavior. Do not assume human-like thought if association or habit is enough. Morgan was not trying to eliminate anthropomorphism completely. Anthropomorphism means attributing human characteristics or mental states to animals. Morgan knew that researchers might need to make some inferences about animal minds, but he wanted to reduce the careless use of anthropomorphism and give comparative psychology a more scientific basis. He attempted to observe animal behavior and explain it while applying the law of parsimony. He avoided attributing higher-level mental processes to animals when lower-level processes could explain the behavior. Morgan believed most animal behavior resulted from learning or association based on sensory experience. That kind of learning was considered a lower-level process than rational thought or complex ideation. This refined Romanes' method of introspection by analogy. Morgan did not completely abandon the method, but he made it more cautious. He helped shift animal psychology away from charming stories and toward more disciplined interpretation. Morgan was also the first scientist to conduct large-scale experimental studies in animal psychology. His experiments were not performed under the rigid scientific conditions required today, but they did involve careful observations of animal behavior. So Morgan matters because he brought restraint. He made comparative psychology more scientific by saying, before you credit an animal with complex reasoning, make sure simpler explanations are not enough. That principle is still important in animal cognition today. Part 8. Spencer and Social Darwinism. Now we turn to Herbert Spencer. Spencer became widely recognized for extending evolutionary ideas into a broader philosophy. He is also the person who coined the phrase, survival of the fittest. That phrase is often associated with Darwin, but it came from Spencer. Spencer believed that all aspects of the universe evolved, including social institutions and human character. This led to what became known as social Darwinism. Social Darwinism applies evolutionary ideas to human society. In Spencer's version, if the principle of survival of the fittest operates freely, then only the best will survive. He believed that if society did not interfere with the natural order, human perfection would eventually result. This idea became especially popular in the United States. Many Americans opposed government regulation of business, industry, and welfare. Individualism and laissez-faire economics were seen as vital. The belief was that people and organizations should be left alone to develop in their own ways, much like living species adapt to their natural environments. People, programs, institutions, and businesses that could not adapt were expected to fail or disappear. Supporters believed this would improve society as a whole. They argued that if poorly functioning enterprises survived, they would weaken society and violate nature's supposed law that only the strongest and most fit should survive. Spencer believed that by ensuring only the best survived, society could eventually achieve perfection. That is the theory. But again, historically, this idea was used to justify inequality, neglect, and lack of social support. It treated social failure as evidence of biological or moral unfitness, rather than considering structural barriers, exploitation, discrimination, poverty, or unequal access to resources. So, social Darwinism is another example of how scientific ideas can be extended into social policy in dangerous ways. Part 9: Why America Welcomed. Spencer, America's individualistic spirit, welcomed Spencer's message. Phrases like survival of the fittest and the struggle for existence became part of national consciousness. The United States seemed, to many people, like a living embodiment of Spencer's ideas. Hardworking people believed in free enterprise, self-sufficiency, and independence from government regulation. On the Western frontier, everyday experience appeared to demonstrate principles of natural selection. Survival depended on adapting to a demanding and often hostile environment. Those who adapted survived. Those who did not adapt often failed or died. That frontier logic made evolutionary language feel practical and familiar to many Americans. The United States was also oriented toward practicality, usefulness, and functionalism. That made America more receptive to evolutionary theory than some other nations. Spencer's views fit the American ethos. His philosophical system influenced many fields of learning. He also developed what he called synthetic philosophy, which applied evolutionary principles to human knowledge and experience. Spencer believed the mind exists in its present form because of past and continuing efforts to adapt to various environments. He emphasized the adaptive nature of nervous and mental processes. He also argued that increasing complexity of experience is part of the evolutionary process. In his view, every organism must adapt to its environment if it is to survive. This way of thinking deeply influenced American functional psychology. If the mind evolved, then the mind must have adaptive functions. That idea shifts psychology away from the structure of consciousness and toward the use of consciousness, and that sets the stage for William James. Part 10: Pulling it all together. So let's pull the episode together. Darwin changed psychology by making adaptation central. His theory encouraged psychologists to study animal minds, individual differences, development, function, and behavior in natural context. Galton extended Darwinian thinking into the measurement of individual differences: mental testing, heredity, statistics, and eugenics. Romanes opened the door to comparative psychology by collecting observations of animal intelligence and arguing for continuity between human and animal minds. Morgan corrected Romanes' overreach by proposing parsimony and encouraging more cautious, scientific interpretation of animal behavior. Spencer extended evolution into philosophy and society, creating a version of social Darwinism that fit American individualism and helped shape the functionalist climate. This episode shows how evolution changed psychology's central question. Psychology was no longer asking only, what is consciousness made of? It began asking, what does consciousness do? How does behavior help organisms adapt? How do individuals differ? How are humans connected to animals? How can psychological traits be measured? And how do social values shape scientific theories? That last question matters, because evolution gave psychology powerful tools. But those tools were also used to justify harmful ideas. So we have to study this history with both appreciation and critique. The big takeaway from today's episode is that psychology changed through argument, measurement, method, and cultural pressure. The names matter. Darwin matters, Galton matters, Romanes matters, Morgan matters, Spencer matters, but the pattern matters more. Each figure is responding to a problem left behind by the last one. Darwin gave psychology adaptation and continuity. Galton turned variation into measurement. Romanes pushed animal minds into psychology. Morgan demanded more scientific caution. Spencer connected evolution to society and helped shape the American appetite for functional thinking. Together, these figures helped move psychology toward function, adaptation, comparison, and individual difference. And that movement prepares us for the next major figure, William James. That's where we'll pause today. Until next time, keep following the evidence, watching the assumptions, and noticing how the past still lives inside the present. This is Dr. Jackal, signing off.